Welcome to the session on algebraic methods. In this session, we will be looking at review exercises. The objectives for this session are to review previous topics through exercises, namely, simplify algebraic expressions, factorize quadratics, carry out long division, find the equation of the line passing through pairs of points, and complete the square for quadratics. Pause the video and have a go at these review exercises. When you are ready to view the solutions, press play. Before we tackle the exercises, we're going to look at some of the laws of indices. The laws of indices shown on your screen can be used to simplify powers of the same base. Here's a to the m times a to the n. This simplifies to a to the m plus n. We've added the indices. A to the m divided by a to the n simplifies to a to the m minus n. A to the m raised to the power n is equal to a to the power m times n. And finally, ab all raised to the power n is equal to a to the n times b to the n. So let's have a go at exercise 1. Simplify the expressions shown on your screen. We will proceed to solve exercise 1a. We are required to divide each term in the numerator by the denominator, as shown, and then apply the law of indices highlighted. So we subtract the indices in both places, and then tidy up. Now for exercise 1b. We are first going to rearrange the expression to facilitate simplification. So put the constants together here, so 2 times 3, and the x's together, so here x squared times x to the 7. Now let's tidy up. 2 times 3 is 6, and for the time being we're leaving x squared times x to the 7 as it is. And x to the 2 times x to the 7, we simply add the indices to give x to the 2 plus 7 as shown. And finally tidying up gives 6x to the power 9. And now for exercise 1c. Again, we will rearrange the expression to facilitate simplification. 16 divided by 4 is 4, and leave the rest as they are for the time being. Put the x's together and bring the y's together. So in fact what we're actually doing is bringing the denominators to the numerator and changing the sign. Next we add the indices as shown, and finally tidy up. Let's now consider what happens when we factorize a quadratic, ax squared plus bx plus c, where a, b and c are real numbers and a is not equal to 0. The first factorising method we're going to look at is this one. So let ax squared plus bx plus c equal 0. Then we use the formula x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. This formula is either going to give 2 real roots, or 1 repeated root, or no real root. So let's have a go at exercise 2a to illustrate this. We're going to factorise x squared minus 7x plus 12. So let's put this equal to 0 first. Then factorise using the formula. We insert a equals 1 here, b equals minus 7 here, and c here. Then we tidy up. To obtain x equals 7 plus or minus 1 all over 2. So either x equals 7 plus 1 over 2, or x equals 7 minus 1 all over 2. So tidying up gives us that x equals 4, or x equals 3, as shown. So therefore, factorising gives us that x squared minus 7x plus 12 is equal to x minus 3 times x minus 4. So we have two real roots, x equals 3 or x equals 4. Let's now take a look at another factorising method. First, find two factors of AC which add up to b. Then rewrite b as the sum of these two factors. Next, factorise each pair of terms. And finally, take out the common factor. So let's apply this method to exercise 2b. We are required to factorise 1x squared minus 7x plus 12. The factors of AC equals 12 are 112, 2 6, 3 4, minus 1 minus 12, minus 2 minus 6, minus 3 minus 4. Now, which of these factors add up to minus 7? Out of these factors, only minus 3 and minus 4 add up to minus 7. So let's rewrite this equation, and in particular we rewrite minus 7x. So x squared minus 7x plus 12 becomes x squared minus 3x minus 4x plus 12. And now factorise each pair of terms. So x squared minus 3x becomes x times x minus 3, and minus 4x plus 12 becomes minus 4 times x minus 3. As you can see, x minus 3 is common to both parts, so we take out the common factor, as shown. And x minus 4 is the other common factor. We now divide a 6-digit number by a 2-digit number. So let's look at exercise 3a to illustrate this. Divide 278,643 by 25. Set up the division as shown. Begin on the leftmost end of the 6-digit number. Check how many times 25 goes into 2. Clearly, there are no 25s in 2. So we put nothing here. Now check how many times 25 goes into 27. There is one 25 in 27. So we put 1 here, as shown. Now multiply 25 by 1 to give 25, and put 25 here. Subtract 25 from 27 to give 2. Bring the 8 down and position it here, as shown. How many 25s are in 28? There is one 25 in 28. Position the 1 here, as shown. Now multiply 25 by 1 to give 25, and put 25 here. Subtract 25 from 28 to give 3. Bring the 6 down and position it here, as shown. How many 25s are there in 36? There is one 25 in 36. So position the 1 here. Now multiply 25 by 1 to give 25 and put 25 here. Subtract 25 from 36 to give 11. Bring the 4 down and position it here. How many 25s are there in 114? There are 4 25s in 114. Position the 4 here and then multiply 25 by 4 to give 100. Subtract 100 from 114 to give 14. Bring the 3 down and position it here as shown. How many 25s are there in 143? There are 5 25s in 143. Position the 5 here and then multiply 25 by 5 to give 125 as shown. And then subtract 125 from 143 to give 18. So dividing 278,643 by 25 gives 11,145, remainder 18. So we have that the quotient is equal to 11,145 and the remainder is equal to 18. Let's now have a look at exercise 3b. Divide 620,967 by 125. Set up the division as shown. Begin on the leftmost side, so check how many times 125 goes into 6. Clearly there are no 125s in 6, so we put nothing here. Then check how many times 125 goes into 62. There are no 125s in 62, so we put nothing here. Now check how many times 125 goes into 620. Clearly there are 425s in 620, so we put 4 here. Multiply 125 by 4 to give 500. Subtract 500 from 620 to give 20. Bring the 9 down. How many 125s are there in 209? There is 1. Position it here. 1 times 125 is 125. Subtract to give 84. Bring the 6 down. (846) divided by 125 gives 6. There are 6 125s in 846. Multiply 6 by 125 to give 750. Subtract to give 96. Bring the 7 down. How many 125s are there in 967? There are 7. Position the 7 here. 7 times 125 gives 875. Then subtract to give 92. And so dividing 620,967 by 125 gives 4,167, remainder 92. So we have that the quotient is equal to 4,167, and we have that the remainder is equal to 92. Now let's take a look at exercise 4a. We're going to find the equation of the line passing through a equals 0 minus 3 and b equals 2, 5. The points are plotted on the graph as shown. The gradient of this line is change in y over change in x. Change in y is 5 minus 3, and change in x is 2 minus 0. So the gradient equals 8 over 2, which equals 4. Hence substituting in y equals mx plus c gives us y equals 4x plus c. Now substitute 2, 5 in the equation to find c. Plug in y equals 5 here. The gradient is 4. And plug in x equals 2 here. Tidying up gives 5 equals 8 plus c, and hence c equals minus 3. Therefore the equation is y equals 4x minus 3. As shown. Now let's have a go at exercise 4b. Find the equation of the line passing through c equals 8 minus 7 and d equals minus 6, 4. Plot the points on a graph and join the points with a straight line, as shown. The gradient m equals change in y over change in x. Change in y is 4 minus 7. And change in x is minus 6 minus 8. This equals 11 over minus 14. Hence the equation of the line so far is y equals minus 11 over 14x plus c. Now let's substitute 8 minus 7 in the equation to find c. Substituting y equals minus 7. Minus 11 over 14 is the gradient. X equals 8. And here's c. Now rearrange to find c. And tidy up to give minus 10 over 14. Therefore the equation is y equals minus 11 over 14x minus 10 over 14. We can now multiply through by 14 to give 14y plus 11x plus 10 equals 0. And now for exercise 5a. We are required to write x squared plus 6x plus 18 in the form x plus p all squared plus q. Now if we apply the completing the square formula to x squared plus 6x plus 18, we obtain x plus 6 over 2 all squared minus 6 over 2 all squared plus 18, as shown. And then tidying up, to give x plus 3 all squared plus 9. Now let's have a go at exercise 5b. We are required to write x squared minus 8x plus 6 in the form x plus p all squared plus q. So let's solve this. We can rewrite the expression as x minus 8 over 2 squared minus 8 over 2 squared plus 6, as shown. This simplifies to x minus 4 all squared minus 4 squared plus 6. And simplifying further, we obtain x minus 4 all squared minus 10. And this is therefore in the form x plus p all squared plus q. So far, when we've used the completing the square technique in this session, we've applied it to quadratics of the form x squared plus bx plus c, where if we look at the quadratic ax squared plus bx plus c, the a is equal to 1. What happens when the a is not necessarily equal to 1? In this situation, the completing the square formula is given on your screen as shown. Let's have a look at how we can apply this by applying it to the next exercise, 5c. Solve the equation x squared minus 6x minus 18 equals 0 by completing the square. Give your answer in surd form. So let's apply this to our example. Here we've input a equal to 1 and b equal to minus 6 in our formula as shown. And now c equals minus 18, and here a and b again. And tidying up gives us x minus 3 all squared minus 27 equals 0. So now let's solve this. We now rearrange this so that it can facilitate square rooting as shown. And so if we square root, we have x minus 3 on the left-hand side equals plus or minus the square root of 27 on the right-hand side. And then isolating the x gives us x equals 3 plus or minus 3 root 3. And of course here we know that root 27 equals 3 root 3. This brings us to the end of this session. If you have understood its contents, you should be able to simplify algebraic expressions, factorize quadratics, complete long division, find the equation of the line passing through pairs of points, and complete the square for quadratics. Thank you very much for listening.